This is Dennis. I had several questions from different students about how to write to and read from a binary file. One of the first things to take note of with a binary file is it is what's called a sequential access file. So I can move back and forth on the file and I can access different number of bytes. So I can move forward 15 bytes and then get read 15 bytes and so on. So in this program, to demonstrate, the first thing I did is I just created a simple one-dimensional array and I populated it with integer data. So I believe I have 16 numbers here, and that's why eSize is set to 16. I call a function that's going to display that data just to show you that it's actually in that array, and then I'm going to talk about this function to save the data. Okay, so before I run it, I want you to look at the save the data function. So the first thing I do in save the data is I create a file pointer variable that's going to point to a file out on my disk system. I use that file pointer variable with an fopen statement, and I'm trying to open a file named BinarySave.bin, and I'm trying to do that for writing as binary. If this is successful, this is going to hold, PTR is going to hold a hexadecimal address. If it's not, PTR is going to equal null. So the first thing I do is I test to see if it was successful. So if it equals null, I'm going to say not able to write to the data file, and I'm going to pause so they can read it, and I'm just going to do a hard exit. If I get to line 57, that means I have the file open for writing, and I'm ready to rock and roll. So the first thing I'm going to write is I'm going to do an fwrite, and the first argument of fwrite is the address of. So I'm going to fwrite the address of eSize. I'm going to save eSize, which is 4 bytes, so size of int 4 bytes, and there's one 4 byte to this pointer or to this binary save.bin document. I'm going to save that first so that when I reload this information, I will need that to be able to know how many elements are in the array. After I save the first 4 bytes, I'm going to save the next 16 elements of the array, 4 bytes each, with this statement. So I'm going to do an fwrite, writing out the array, size of int, which is a 4, and I believe it's 16 elements, and that's going to be saved. Once I do that, I'm going to close the pointer, and I'm going to say data has been saved, pause, and I'm going to go back up here in main. So let's watch this run and make sure it works, and then we'll move forward. All right, so I'm back. I'm going to run it. And the first thing we're going to see is there's the display data. So there's the the 16 elements of the array, and there's what's stored in each one. It says data has been saved, which means that save data function should have worked. And the program ends. So I'm going to use Explorer to look to see if this binary save.bin was created. And it was created today, June 11th at 2:12. And it tells me I have a binary file. If I look at the properties, it's going to show me how many bytes are actually in that file. So as you can see, there's the size, and I could say 4 times 16 plus 4 should be where I'm at as far as the size. I'm going to say OK. Okay, now I'm going to show you how the reload works. So the first thing I'm going to do is I'm just going to comment out this, and I'm also going to set eSize back to 0. eSize back to 0. So let's do that. So when I run this the next time, the array is going to be empty and the effective size is going to be 0. So when I run it this time, I'm going to run this load data function. I'm going to display the information and then I'm going to save it again. Not that I need to save it again. Let's take a look at the load data. So the load data is very similar to the save data. So here's the save data. The only difference is the fwrites and the fopen statement. So in the load data, the first thing I do is I create a file pointer variable, and then I try to open it. Notice this binary save.bin is going to be in the same folder as my source document. I can put it anywhere I want. This time I'm opening it for reading. and I'm going to test to make sure I was able to open it. If I get to line 42, that was successful. The key thing to note is I'm passing the array by reference and I'm passing the effective size by reference. The reason I'm passing the effective size by reference is I'm going to be changing it. So the first thing I'm going to do is do an fread. The first argument of the fread is the address of the data. Well, I pass it by address, so this is the value of the data. Without the asterisk is the address. So there's my e-size without an ampersand. That wouldn't make sense to say an address of an address. So I have to realize what this is, and this is an address. This could be just the number 4, but I like to use the size of function, which returns 4. Size of n is 4. And how many 4-byte things do I have? 1. And I'm going to get this from this pointer, which is the binary save.bin. Now that I have the effective size populated, I'm going to reload the array. So here's the array. I'm going to load it by address. That's what this is without any ampersands. Size of int 4 bytes. And now I need to say how many things am I loading? Well, this should equal 16 if I did this right. Notice the asterisk this time, and I'm getting this from the pointer or this location. Once I load it, I will close it. I will let the user know the data has been reloaded or brought back. Pause so they can read it, and that's it. Back up here in main. I'm going to display the data, and then I can save it again, or I don't really have to. So if this works, it's going to be the exact same output as before, but notice this time, notice this time I commented this out, so I'm not defaulting it to anything. So actually, I'm going to just put zeros everywhere. All right, so the effective size is 0. So if load data writes, it works correctly. In essence, the effective size is going to become 16, and all this data is going to come back. Let's run it, see if it works. And obviously, it doesn't. Hopefully, you were screaming, hey, you commented out the semicolon. Now it should work. Let's make sure that's true. So it runs, and it tells me the data has been reloaded. There's the data. It's back, and it saved it again. So if I would add any more data in the middle, when it comes back, that data will be there. So let's take a look one last time, and we'll wrap this up. We know how to do the display data. Here's the load. So I create a file pointer variable. I do an fopen read binary. I make sure it worked. I read in the address of e-size without an asterisk or an ampersand. I have one e-size variables. Then I read in the address of the array, which is just the word array in this case, size of int, which is 4 bytes. This time I need the asterisk because that's going to get me my 16, and I'm going to pull that from where this pointer is pointing. When I'm done, I close it. Data's been reloaded, and that's it. Don't want to bore you any more than that. Hopefully this makes more sense to you, and have a good day.